Welcome to my second podcast on partial fractions. We're going to look at an unusual situation that is very easy to deal with, but it does require an extra step. So in this particular instance, you'll notice that the degree of the polynomial in the numerator is the same as the degree of the polynomial in the denominator. That does not make partial fractions a practical alternative unless we reduce the fraction by using long division. By using long division, we can create an integral that has a a fraction in it that we can use partial fractions on. Let me show you what I mean. So I'm going to take the x squared plus 0x minus 6. I'm going to divide into that the x squared minus 9. So as you can see, x squared goes into x squared one time, the x squared minus 9. And when we subtract, right, you'll notice that we get negative 6 plus 9 is 3. So what we're really saying is that this is really the integral of 1 dx plus the integral of 3 over x squared minus 9. So again, the long division gives us the ability to, I guess, reduce. In some way, we're actually reducing this to a mixed number of some degree, however you want to call it. But what it gives us is an integral that we can actually use partial fractions on. So let me clear out the long division part, since that's not really necessary anymore. And let's go ahead and look at how we're going to really solve this integral now that we have exactly what we want. Well, the first integral is pretty simple, isn't it? In fact, I'm not really going to work it out quite right now. I'm going to work out the second integral. In order to do that, I'm going to have to remember that x squared minus 9 factors as x plus 3 times x minus 3. So those are my factors of x squared minus 9, and now I'm going to go ahead and solve for a and b using the process that I used in my earlier podcast on partial fractions. So I have a times x minus 3 plus b times x plus 3, all that equaling 3. So I use the process that I used before. I'm going to set x equal to 0. I'm sorry, 3, obviously. So that factor is equal to 0. And so that's going to give me 3 is equal to a times 0 plus b times 6. And so I can see that b has to equal 1/2. Repeating the process, this time setting x equal to negative 3, I get that 3 once again is equal to a times negative 6 plus b times 0, and that makes a equal to negative 1/2. And so now I can do my integral by using these partial fractions, right? So what I've really got here is the integral that we started with is really equal to the integral of 1 dx plus, I'm going to use the positive one first. This is going to be 1/2 times the integral of 1 over x minus 3 dx minus 1/2 times the integral of 1 over x plus 3 dx. I'm going to erase my partial fraction work from the work I did to find my numerators for the partial fractions. And we'll just get this finished off now. So my final answer is going to be obviously x plus 1/2 ln the absolute value of x minus 3 minus 1/2 times ln of the absolute value of x plus 3. Now, just because I can, I'm going to show you that I can combine these two by doing something as simple as this, x plus 1/2 times the quantity. Now, I'm going to factor out the 1/2, but then what I'm going to do is I'm going to put the x minus 3 over the x plus 3, since they're being subtracted, and that's plus c. And I can go one step further, and that is our answer ends up becoming the natural log of the square root of x minus 3 over x plus 3 plus c. And that's our final answer.